All right. So here's a few news articles. Um, this one I thought was pretty fun. The QAnon people are going through a crisis, of course, because they expected that Biden would never get into the presidency, that there would be some mass arrests or revolution or something putting Trump in charge. And now they're all having various crises of faith as their crazy religion is being proven crazy. And here's the Flat Earth movement. This is a real group explaining to the QAnon people that they're too crazy. So that's kind of hilarious. Anyway, so Google fired an artificial intelligence ethicist, and now they are investigating another one to fire them. And in both cases, it's because they want to criticize what Google is doing internally. And as you probably know, Google originally started planning to be a very moral company with a don't be evil motto. But when they incorporated, they had to drop that and move into the old business model where you just make money by any means necessary, largely. And many internal people at Google are more and more upset about things Google does. And so their point here is that people are looking through they were triggered on by automatic defenses on the Google network that someone was scanning through messages looking for examples showing discriminatory treatment. And so they want to like punish and fire these people for doing it, just like they're punishing and firing people who start forming unions. So, you know, Google is increasingly just acting like every other large corporation where they, am I muted? People can't hear me? I'm not muted. Can anybody hear me? According to, looks like, oh, you can hear me. Go to you. All right, good. Fair enough. Anyway, so various people are getting upset about Google, and we'll see what comes of all that. This is something the guest speaker last night talked about from FireEye, that a couple of years ago, Israel had responded to hackers by locating their building and figuring out they were on the third floor and then taking them out with an airstrike. And they sent them a message before saying, evacuate the building because we're blowing up in 15 minutes. And so they did. So, you know, it's the geolocation of internet property has gotten very good. And, you know, it's the difference between physical strikes and cyber strikes. The two are more connected than people thought they were in the past. Anyway, these fiber home routers, which apparently are not used in America but other nations, really sound like a horrible mess. The cheap home routers tend to be terrible. They found 28 backdoor accounts. This was in South America and Southeast Asia. They're using these things. And so they've got a bunch of hard-coded credentials. And in something that I find amusing, because I was giving talks about this a long time ago, they protected the IP version 4 interface with a firewall, but the firewall does not detect IP version 6. And then they upgraded the router to IP version 6 without dealing with that. So the IP version 6 interfaces are nakedly exposed to the internet, which is a very common issue as people have security devices that are not 6 aware. And they often do not understand that IPv6 is turned on their networks. Anyway, so they also had another really old trick. There's a key, but the key is calculated from the MAC address. And the MAC address can be detected. There's a page that leaks out the MAC address and so on. This is a really old trick. People treat the MAC address as a private key. For a long time, cell phones, they would treat one of the internal numbers like the IMEI address as a trustworthy private key. And, you know, in both cases, it's not good enough. It can't be changed. And there are ways to find it out. So they also had a certificate that was just sitting on the device. So you can find it and then it never changes. Fox News, as we know, there's going to be a huge political turmoil in America now. Now that Trump is out, everyone's going to have to figure out what to do about that because he dominated politics so much and shifted it so far from where it used to be. Fox seems to have decided that what they have to do is get rid of the real journalists and stop having real news and have nothing but alt-right opinions that lie. So they're trying to, I guess, compete directly with OAN and such. I mean, a while ago, Murdoch said he was done with Trump and told them to call it for Biden and quit coddling Trump. But a lot of people don't agree with that. So apparently they're going to move back towards the alt-right and stop pretending to be a real news agency. And in the same spirit, the security at the inauguration today, a lot of people, including me, were concerned because so many police and military are in fact Trump supporters. And they Yes, of course, their opinionated segments make Fox more money. But when Trump actually staged a violent coup attempt, a bunch of people turned against him, including Fox News. And even before that, when he claimed that he had won when he clearly lost, a lot of people began to lose faith, although not the Republican voters. So anyway, they found a dozen National Guardsmen that they decided were showing signs of being in the alt-right and otherwise disturbing, and pulled them out. And apparently they did pull off the inauguration without any major security problems. So they were successful at thwarting insider attacks, such as there may have been. And anyway, in Thailand, you do not have free speech. You cannot insult the monarchy. And this woman got 43 years in jail for insulting the monarchy on Twitter or online somewhere. So that's she's far from the first doing that. They have a less majest article there that you must not defame the dignity of the monarch by criticizing them. I know I have students that come from other countries to America, and they're all amazed the way we pick on our president and call him an idiot and say he's rotten and make cartoons of him being a pig and stuff. You can't get away with that in other societies, but in America you can because of the First Amendment.
What?
Anyway, but this is the thing, 35% of Americans say they have doubts about who won the election, and 21% approve of the storming of the Capitol, which is the majority of Republicans. So that's why we have, a very strange divided country right now. And we will see what comes of it all. Trump may form a third party or something, but there's a large portion of Americans that are very, very much not on board with our current democracy and would much rather have something like a monarchy with Trump in there, with the elections just canceled entirely or rigged like Putin to always have the person they like win the election. And we'll see if they succeed. Anyway, we're down to just about the time to get started with. Is there a problem with the share? Can you folks see the desktop I'm showing? You should be seeing my homepage. People can see it. Okay, fair enough. Anyway, the share screen is stuck, someone says. Just see Fox News. I don't think so. That's strange. I'm not even sharing Fox News. Well, I'll stop the share and start it again. Let's see if that helps. Share desktop 2. All right. So you should see the 128 page coming up. Is it coming up? See the 128 page? All right, fair enough. It looks like it's working. This is one weakness of my system. It'd be better if I had another computer here to give me feedback so I can see what you're seeing, but I rely upon you to tell me. All right, so here we are. This is CNET 128, hacking mobile devices. And you, by the way, can get free access to the textbook through something called Safari Online. And here's the web application Hacker's Handbook, which is what we're going to use. All right. And so we're going to do Android primarily, but some iOS optionally. The problem with iOS is that you need real devices. I will have some iPhone 6s that we can jailbreak and play with, but you'll have to really get a physical device. And a lot of students won't be able to do that. So the iOS stuff I made optional, but it is very interesting. Anyway, so you do not, of course, need to attend physically. You also don't need to attend in real time. You can just watch videos or read the book. Everything is asynchronous. There's a Canvas website. If you're a City College student, use the official City College website. Other than that, there's another Canvas website here that you can use for everybody to join. And on there, you'll find the quizzes and how to turn in places to turn in the projects. Quizzes and final exam are on there. And there's a discussion board where you should discuss concepts. After the first 2 weeks, there are discussions that are due. And would it be possible to do the iOS on an old iPad? Yes, probably. It has to be a certain range if you want to jailbreak it, as you'll see. I'm using, you don't need ad codes. Ad codes don't exist anymore. And this course was not full, so everyone should have been able to just enroll. So just try enrolling, and if you get any trouble, let me know. Oh, by the way, if you want to contact me and you can't do it through Canvas, then email this address. If you email my general address, I might not notice it because I get too many emails. So, but anyway, email this one and my very efficient grader will find it. But you shouldn't need ad codes. As far as I can tell, ad codes are over. They've been over for a couple of years. You should be able to just add these days. If too many people add, then I have to approve them, and I'll just approve anybody. All right. So anyway, I'm just going to today just introduce the concepts with the talk I just gave at DEF CON, which is a talk on mobile apps. I've been giving talks there about mobile apps for several years now. From teaching this course, really, and going through the first textbook, I found out how to do some simple tests to detect some simple mobile app defects. And then I just started checking mobile apps, and I've checked, must have audited more than 1,000 mobile apps by now. And it is just awful, which I found very interesting. I mean, mobile apps are terrible. It's like hacking 20 years ago. These people just have no clue at all. And so I summarized my findings here, and I'll just mention this to give you an idea as an introduction. So you know who I am, I think. And you should all be on Twitter if you're not. I'm at Sam Bound. Twitter is the standard for the information security community, and you should all be on there. Anyway, but mobile app standard securities are spectacularly poor. And one thing I did not know and only found out about recently is that iOS apps are just as bad as Android apps. I had heard that. But I was not able to do much testing of iOS apps until we had CheckRain, the jailbreak. But now that we do, I'm able to test iOS apps. So I tested several hundred of them and found that indeed they are just as bad. And by the way, the most important flaw of a mobile application is not on the phone. It's the API, which is the program running on the server that takes requests from the phone. And APIs are spectacularly insecure. And as we'll see, that's actually where most of the flaws are. And all these flaws are, that I can find, are incredibly simple, and management should be able to block them. Even fairly non-technical management should be able to block them. So anyway, the Owasp is the Open Web Application Security Project. It's an open source group containing members from all different technical companies and just a lot of anybody that wants to join, really. And they set standards. And one of the things they do is they have a top 10 vulnerabilities for web applications and mobile applications and also APIs now. And so here's the mobile application top 10. And you'll see a variety of ones here that we're going to go through quite a bit, like storing data on the phone insecurely, sending data over the network insecurely, not using cryptography correctly, and allowing people to modify the app and continuing to let the modified app work. These are the ones we're going to play with in this class a lot and exploit a lot. So here's the worst apps I've found. This one here we're going to use quite a lot, Equity Pandit. This is a real financial company in India, and they have the worst app I have ever seen. And I told them about all this years ago, and for years I've been using them. This app is amazing, and they claim they even have a certification, although this is not a security certification. It is a technical certification, and they claim to be the leading financial app in India, and their app is so amazingly bad. It's worse. At one time, I found out how to modify the app, and I was going to modify it to make more entertaining homework for my students, and I found out that the original app was worse than anything I had thought to make a bad app. If you log into somebody's account and you type in the wrong password, it tells you the right password for that account. Everybody's password is just being broadcast unencrypted over the internet to anybody who asks. And it's been this way for years, and they just don't care. I don't understand how anybody can even run a company like this or run an app like this, but they just don't care. And apparently their customers don't care. So when you do this project, you'll have flags to find. And one of the flags is to find my password because it will just tell you my password. It's just mind-boggling. I don't know if they have security laws in India, but it seems to me like this ought to be illegal, but nobody seems to care. Now, in America, they do care somewhat. And so when I do a lot of college apps because I have an association with colleges. And so I checked out the University of Houston apps, and they had an alumni app. And alumni apps are where you get in contact with the people who have graduated who you're trying to get money from, donations from. So they're people you really want to treat well. So they made a special app for them, and they made it look pretty, but it has a place where you can fill in a form with the first few letters of your address, and then it will search, and you can pick yourself from the list. But if you capture the traffic that's sent over the network at that time, the traffic, I noticed, I sent a request for like first name starting with A and a second name starting with A. And that request is only 426 bytes going to the server, but the response was 351 kilobytes, which is an awful lot of data for just one person's profile or one list of page of the directory. And when I looked at it, it sent me the entire database. Every time you search for anybody, before you've logged in anywhere, it sends you the entire database, home phone numbers, passwords for everybody, email addresses for everybody. It's just mind-blowing. It dumps the whole database, sending it to you. And so that's a pretty appalling vulnerability. And so I contacted them, and I've been doing this long enough that I know you never bother contacting a general IT team or a general email address if you can avoid it, because you'll never get anywhere that way. I found the person there who participates in the collegiate cyber defense competition, because people who are on a competition team actually understand how security works. And that way I was able to get it fixed right away. They took it down, they made a new version. You know, it was only less than a day after I told them before this was turned off and gone. And if you try going through normal channels, this will not happen at all. So security is like witchcraft used to be a couple centuries ago. There's a small group of people, you talk a funny language, you have to reach the people that are in the know, that understand that there are vulnerabilities. And when someone reports a vulnerability, what you have to do is actually fix it. Normal people can't understand any of this. All they will ever decide is that you're evil, you hacked them, you need to be thrown in prison. It's impossible that we've done anything wrong. That's what you get from normal people. So you have to get to people that are inside the security community if you want to do any kind of vulnerability report and get anywhere. And so I did a lot of Android apps. I did these in 2015, 6 years ago now. All the top 10 banks, insurance companies, and stockbrokers will be using these. They're all significantly vulnerable. These are all vulnerable to code modification. You can download the app. You can remove the Smalley code, which is very close to source code from it. You can modify it and make a modified app that does something like send an extra copy of the password somewhere else so you can steal it and continue using it, and it'll work just fine. So they're all vulnerable in various ways, and none of them cared. None of them would patch that problem. A few of them would patch broken HTTPS. Anyway, that's the game. Android apps are easy to reverse engineer. People that are used to writing PC programs in languages like C++, like Microsoft Word, the developers often imagine that the end user cannot modify your program because the compiled program is in machine code, and that's hard to fix. You can do it, and we'll do it in the exploit development class, but it's hard. But in Android, you're writing Java, and Java does not compile to machine code. Java compiles to bytecode, which is Smalley in the case of an Android phone, and Smalley is actually very easy to read and modify. So I took the TD Ameritrade app and modified it. So when you send in your name and password, it sends an extra copy of the password into the log. And then I notified them. And the next month they had an update. And now when I tried to modify the updated one, there were 2 copies of the password in the log because they modified their code to put a copy of the password in the log. But anyway, this is the one they put there. The password's just sitting in the log. And this is a security flaw. Especially in older versions of Android, the syslog is available to every other app on the device, so it's an unsafe place to put secrets like passwords. Anyway, here's one, the Mayo Clinic Medical Transport. This one here has a password from this group called Wolf Apps. You're only supposed to be able to see a private part of the app if you know the password, but all you have to do is download the app from the phone, which we'll do in the project, and unpack it, and then just look, and the password is just sitting there. There's a parameter called secret password that has the password right there. So it's not hidden very well at all. And this is like that router I was talking about at the beginning of the news section. They just have a hard-coded password sitting around, and it's easy enough to find. You know, this is not the way to do it. All right. So some of these flaws are so bad you can actually get punished. Code modification, I hear you question, why is code modification a security flaw? It's a security flaw because it means I can make a poisoned version of the app. And now, if I can trick people into installing that, they will be doing something unauthorized, like sending me their password so I can get in their account. So if everybody got everything from only the official Google App Store, and if the Google App Store only took authorized apps, then it wouldn't be a flaw, I suppose. But in fact, many people go to non-Google sources of their apps, especially, for example, in China, where they block Google. So they go to unauthorized websites, and a lot of people download apps from other websites too. So if people say code modification is the mobile equivalent of phishing, yes, I think it is. That's a fair statement. In phishing, you make a fake website that looks like the bank website, and you trick people into going there. And in code modification, you'd make a fake app and trick them into somehow using the fake app. So you would send them some kind of message saying your app needs to be updated. You use this new version. Yeah, that's it. Yeah, that's a fair comparison. Good. Anyway, if you break HTTPS by using unauthenticated certificates, so people can use fake certificates, that actually has been punished in small ways by the Federal Trade Commission in America. Fandango and Credit Karma were actually punished in court for using broken HTTPS. That was considered insufficient security to live up to a standard claim. The main thing the Federal Trade Commission does is they just make sure that you do what you say you're going to do. And almost everybody has in their terms of service some kind of boilerplate statement like, we protect your data with normal security measures as standard for our industry or something. And this practice of not verifying certificates is not considered good enough in America. Anyway, and so next thing is, most people don't want to keep typing their password on the phone. So once you log in, the app remembers that you're already logged in on that phone for a long time. So how does it do that? Well, now websites have had a remember me button for many years, and they have a fairly good way to do it. And here's the right way to do it. I went to the Target app, or retail store. So I went to Target Australia's app, and this one does it correctly. You install this app, and then when you log in, I send it a post, and in here goes my username and password, and that is being sent over HTTPS, so it's encrypted, and this is the right way to do it. So I send my username and password up to the app, and it sends back a thing called a token, and that's just a long random string of letters. That's the right way to do it. You log in, and then it sends you a token, which you save. And then from now on, every time you connect, you send up the token, and it looks on some database on the server and finds that that token proves that you're logged in as you. That's the right way to do it. And the reason you do this is because that token doesn't contain my username or password or any kind of secret. If somebody steals that token, the only thing they can do is use my account on this one-to-one app. They can't possibly go log into some other service with it, which they probably could if they stole my password, because people reuse passwords. So this is the way it's done by web apps and has been done for a long time. So that's the right way to do it. For some ungodly reason, most mobile apps do not do that. So here's an example, Staples, another retail shop, which I did in 2017. You install this Staples app, and when you log in and say, remember me, it stores on the phone this thing called encrypted password, which is just a blob. So right away, this is a problem. Why would you store the password? Even if it's encrypted somehow, what makes you think storing the password in the app's data section is necessary? Why do you even need to remember the password? All you should remember is a token. But they remembered the password. And so here's a website, Android Authority, recommending this. They say, here's how you handle storing passwords. The best way, don't. Why do you think you need to store a password? Whatever makes you think you need to store a password is bad thinking. All you need is a cookie, a random number. But if you have to, use the Android keychain. There is a operating system provided place to put secrets. That's what it's for. Put them in there. Or if you won't do that, you could encrypt it with a public key, and then the private key is on a server. So all they can do is send the encrypted stuff up to the server. It gets decrypted there. That would be pretty good. Yes, if the user changes password, will the token value change? Well, that's actually another interesting issue. On web apps, there is actually a nasty interplay between passwords and tokens. If I steal your cookie from a web app, I can often get in your account, and even if you change your password, I can still get in with the old token. About half the websites I tested a few years ago had that vulnerability. And there is, in fact, often no way to ever cancel an old token without deleting your account on about half the websites. The other half have it. Now, some better websites now have a place where you can see how many sessions are open of my account, and you can cancel them. Like you can do that in Gmail now. said you're logged in on these other 3 devices, so you can notice if some of those are devices that you're done using or that maybe aren't even really your device, you can cancel them. But a lot of websites just have some kind of token generation system where the token just stays valid forever, and that's a problem. These are very good questions. Anyway, encrypting it with a public key, and where all you have is some kind of encrypted data that you send to the server and only the server can decrypt it, that would be pretty good. I've never seen any app that does that. What most apps do is this. They encrypt it with a private key, and then they try to hide the private key on the phone somewhere, which is pointless because I can see your source code. You can't hide anything from me as the reverse engineer because I can read your source code. And of course, some of them still store their data unencrypted on the phone, but they seem to have learned that that's not a good idea. And most of them have moved up to step 4, which is not much better. So here's what you have. Encrypted password is stored here, and there's various tricks. One way to detect a failure of this, a thing I learned from Web Application Hacker's Handbook, is to use 32 identical characters at the beginning of a password, and then you'll know if this is using electronic codebook encryption. And you can tell because this is base 64, this is the stored password, but if you reverse the base 64, it looks like this, and you can see the first 16 characters encrypt to this block, and the next 16 characters encrypt to the same block. So they're using electronic codebook encryption, where every block of input maps to a block of output, and it's a repeated block of input gives you a repeated block of output, which is another weakness of the encryption. So anyway, you can read the code. This is what Smalley code looks like. Username, encrypted password is here. You can read these things. And so you can find out how they construct the key. And this is how the key for one of these apps, I think this might be the Staples app, is made. It takes the brand name of your device, the device name, the model number, serial number, and then the package name, which is the name of the app. It just takes these values and then combines them and runs it through SHA-1. And then takes the first 128 bits of that and uses it for an AES key. So it is a simple transformation of values that are pretty easy to find to create this. Doesn't even use a random number generator or anything. And that's what you could call hiding it on the phone. They just have a simple way to combine a few things that are easy enough to find to make this. It's not all that different than the example in the news where they just take the MAC address of the router and use that to make a key. This is just no way to really hide anything. This is what's called obfuscation. You can argue. But anyway, it's a very poor way to do encryption. It's not really going to keep out anybody that tries to get in, that has any ability at reverse engineering. So anyway, I told these guys, and they told me they were going to fix it. They didn't fix it, and so I made them homework. And then I went to talk to a Congress in Washington, D.C. about it. And then I made some YouTube videos about it, and I gave students homework, stealing personal data from the Staples app. And then I went to Washington, D.C. to give a talk at the ISC Squared Congress. And when I tried to demonstrate it there, they had updated the app, and they updated it so the app won't run on a rooted device anymore. Now, I never got around to testing it further, but what I strongly suspect is that it's still doing the same stupid stuff. They've just made it so that my direct demonstration on that device wouldn't run anymore. But I don't know that. But anyway, this is what you often get. And someone made a good graphic of this on Twitter. This is what happens. We have patched the vulnerability you reported. This is what's commonly the case. They do the smallest possible patch to just get you to shut up. This is security theater, where they want to make it look like they've secured something without actually having to really pay attention and make it secure. But these are the stages through which people go. First, they pretend they have no problems. Then they just try to shut up all the researchers. Then they try to put tiny little band-aids on there so they don't have to work very hard. And it takes many years to admit the painful truth, which is if you publish some kind of product, you're going to have to keep on fixing holes and having patches and updates and responding to vulnerability reports and running bug bounty programs. You're going to have to keep spending a lot more money fixing the program you already wrote that you thought was all done if you want people to keep using it. Anyway, so lots of people store the password in plain text like Ace Hardware and McDonald's. And some people use plain text login where they send unencrypted names and passwords over the internet. That's going out of style. But here it is, a 7-Eleven in Mexico sending your password over the internet with HTTP. And here's broken SSL. I found this app called Price Tracker for Amazon. And I thought it was Amazon at first, but it's some third-party thing that will log into your Amazon account and check the price of something, because Amazon prices change. It will then tell you when the price hits your desired value. So it takes your Amazon credentials and uses it to log into your Amazon account, but it is not an Amazon product. And so I found that it broke HTTPS. I could use a fake certificate and decrypt the traffic, which we'll be doing here. And this is a good question. This was an Android app, but on iOS, it would not necessarily be any more secure. Many iOS apps have the same flaw. Although I didn't test it on iOS at that time, but there's no reason, nothing about iOS would prevent this. So anyway, I found out that this guy actually done this deliberately. That was this one here, fixed the bug causing certain users to see only a blank screen, because when they got a certificate error, they would see a blank screen. So he just removed all certificate checking. And I went back and forth with him trying to convince him that this was a bad idea. And I'm not sure I was ever able to convince him to fix it or not. Anyway, then a lot of them do this reversible encryption, where they encrypt it with a key and then they hide the key on the phone. This is Home Depot, Safeway, Walgreens, and so on. Many companies. Here's the Home Depot encrypted password. And so once you find it, you can then read the app source code and figure out how it works, and then just write a Python script to decrypt it. And we'll be doing all these things in the project. It's not very difficult at all. And you'll see this. There's Walgreens. Here's their encrypted password, this long blob of junk. And the encryption key is always the same. It's calculated from a seed, which is hard-coded in 3 places. So the key is always exactly this value. So all you have to do is decrypt it with that value, and you'll get a blob of JSON, which includes the password. Anyway, then a lot of other ones are out there with these vulnerabilities. A few of them actually fix stuff, like this Golf Galaxy sports place. They actually fixed some things. I think Dick's Sporting Goods actually fixed it. You know, some of them actually fix it when you tell them. Anyway, so I did all that with Android, maybe between 5 years ago and then 3 years ago, something like that. And I couldn't do iOS because iOS, the apps, the operating system is pretty much hidden behind a layer of encryption. But I saw this talk from Joe McRae, who is a fantastic guy. He gave a talk saying reverse exploit development for mere mortals, explaining how to do the real reverse engineering of real binary compiled code, which I always thought was kind of a black art. But he made it look pretty easy. He said, it's not so bad. You should try it out. And so I looked into it, and then I found this book from Georgia Weidman, who is actually one of Joe McRae's students. And her book has a appendix in the back that has step-by-step buffer overflow that works very well. And I was able to finally get it working. So I made a class in this, and we got the Shell Coder's Handbook, and I taught this class. And I was very happy to really do the real binary reverse engineering, which is something I was unable to do before. And one of the students in that class was Axiom X, who was a Google engineer who had worked on iOS and really knew software, but had never done attacks. And Axiom X took this class and then wrote the check rain exploit, wrote the checkmate, and they made check rain. He made a jailbreak. There'd been no public free jailbreak available to give you access to the internal workings of iPhones for about 10 years. And he wrote this, and it is fantastic. And because of that, for the last 2 or 3 years, we have now been able to get inside iPhones again. Because for a while, the only way to get in iPhones was to get really old iPhones that couldn't even run most modern apps. And so there was really no way to do proper testing on iPhones. But now we can. So I got some jailbroken iPhones from him, and I started testing apps to see how iPhone apps are, and they're also garbage. The Blue Cross app stores passwords insecurely. Blue Shield accepts fake TLS certificates. West Point transmits passwords unsafely without encryption. Air Force does the same thing. Zillow caches passwords insecurely on the phone. Stock Option Center, a stock market app, uses plain text authentication. You know, it's just amazing. All the same kind of nonsense is really going on iOS. And this one really got me surprised. It's actually sending unencrypted passwords over the internet. And I saw an article, a news article about 3-4 years ago saying that would no longer be allowed by iOS. A student was asking about this. If you used iOS, it wouldn't have that problem, right? I had that feeling. They gave us the impression that they had updated iOS to where it would stop some of these problems, but that is not true. You have to read the details. I saw this article, Preventing Insecure Network Connections. But it only applies if your iOS app is linked to the newest iOS software development kits. If your iOS app supports the older ones, or if you turn it off in the config, you can turn off this secure transmission feature. And so there are apps that still run on modern iPhones that still send passwords unencrypted over the internet, which is rude, but that's the way it is. And in particular, one of the fun ones is the City College app. This company called Dub Labs made a whole series of college apps, and I found a bunch of them that all send stuff over the internet with broken HTTPS, so it'll accept a false SSL certificate so you can read the data. And I notified them, and I think they've updated it now. But, then I found some financial. This happens a few times. I find not just one bad app, but I find an entire product line that is defective. And then I have like a notification to the company, and I have time to then fix it. So Jack Henry and Associates makes apps for a whole bunch of banks. And again, these all put your password in a log on the phone. And the same thing was true of Fiserv, another whole chain of banking apps. They also put passwords in the log. So all the same flaws that are there on Android also happen on iOS apps, and now we can see them. All you need is a iOS app that can be broken with checkrain, an iPhone that can be broken with checkrain, and that has to be not the very latest, but a certain range of moderately old devices. Anyway, so I've been teaching this hacking mobile device class for several years now, and I've also been teaching a cryptography class because from all this, I became convinced that people are just making ridiculous, foolish decisions about cryptography, and they don't know the essence, so there should be a training class. And so there ought to be management. I'm also teaching management classes like CISSP, because you don't have to be technical. In fact, your management is not really technical. You should ask simple, common sense questions. What data did you collect? Do you really need to collect that data? If you did collect it, where did you put it? Is it encrypted? Where's the key? Simple questions. You should ask simple questions, and there should be good answers for these questions. And if you say, I took the key and hid it on the phone, you should say, wait a minute, that's stupid. That can't be right. Someone could find it on the phone. Don't let them baffle you with technical gobbledygook. You ought to be able to get nice, clear answers to these things. Reminds me when Enron, the crazy company, right? But it's a good picture of like a mean manager. It says, don't give me a bunch of bullshit. I want an answer to this question. Where did you put the password? And how do you know nobody's getting that password? You got to have a simple answer to that question. And that's the thing. And if they give you something complicated you can't understand, you say, no, don't give me something complicated. There should be a good answer to that question. Where's the key? Where did you put it? What is it that means nobody else is going to get it? If they can't give you a good answer for that, don't let them publish that app. Anyway, that's the stuff I wanted to show you. I'm going to stop this recording if I can figure out how to get my button here.